Hello everybody and welcome. It's Hugh here at Loxon and I'm here with our solution for our earlier config challenge. Now, as always, we have a config challenge in the morning and then a solution in the afternoon. If you would like to look back at any of our previous challenges, you can see all of them on this web page here. We have the links to join us live on the live webinars. We have videos, we have PDFs, we have all of the previous challenges, everything you would need to keep yourself well and truly versed with all of the different possibilities of Loxon. And so today's challenge was car park control. And so we have a new car park that is being built for a shopping centre that is going to be free to park in. I know, amazing for the United Kingdom. And what they want though is, because it's going to be an underground car park, they want to know when the car park gets full and essentially block people from being able to enter. And so what we have is 7 parking bays. The reason I said 7 is because we have 7 digital inputs on a mini server, and I want you to be able to test this. This obviously should be scalable, despite whether it's 770, 700, 7,000 parking bays. But each parking bay has a sensor above it that detects when a car's in the bay. When a car's in the bay, the sensor triggers an input. And so when all the bays are full, we want to block the entrance barrier so that people can't drive in anymore. And we also want to change the lights at the entrance to the car park, green or red, to indicate whether there are spaces or not. And then finally, there's an exit barrier, and that is going to be on a ground loop. So as people drive up to the exit, the barrier opens automatically for them. And then finally, as a little extra challenge, I asked people to have an addressable light fitting above each bay that will turn off when a car is in the bay. Brilliant. So now that we've got that out the way, let's get cracking with the config. So I have here a blank config file. I've already connected to this demo case here. Let's get configuring it. So the first thing we need is we need all of those inputs from all of the bays. And so that's what I've done. I've named bay 1 through to bay 7 as my digital inputs. Now, I spent a little bit of time thinking to myself, what is the neatest way to recognize the state of all of these inputs in one go without having to do a bunch of AND blocks? Because I could put, for instance, every 2 of these into an AND block. But that would give me a lot of AND blocks just for 7 inputs. Imagine if we had 70 bays or 700 bays, this config would get unbelievably complex. I then thought, okay, well, what about an add block? Because that gives me up to 4 inputs. Halves my number of function blocks, but it's still a load of function blocks. So I was thinking, is there one single function block that I could put all of the inputs into in one foul swoop? And when I had one of the emails sent in to me of somebody else's config file, Nathan actually solved this. Perfect function block to use would be the door and window monitor, because that has a single input which recognizes each individual digital input that's tied into it, and it has outputs to tell you the total number of open windows or doors. So we can very, very easily repurpose this to be a bay monitor instead. Because it's always going to show the status as open or closed, and I have no way of changing that, I may want to not display it on the app, but let's leave it displayed for the time being. The other thing I need to remember is, because the input is closing when a car is present, I would need to take the inversion off of IW. But then all I need to do is type all of my bays into that IW input. And then what I can do is, on the outputs, I have an output for the number of open windows or doors, and that will provide me exactly that, a number for how many of these inputs are closed. And so what I need to do is I need to take that into a little bit of extra logic that defines whether we're full or not. For me, simplest place to do that would be a status block. So I'm going to rename it car park status. And I'm going to stick this output into AI1. And then on here, if AI1 is equals 7, because there's 7 bays, it means car park is full. Actually, let's do this the other way around. Let's do this 3 and then spaces. So if there is less than 7, so if the number is less than 7, it means that the car park is free, because it means there is at least 1 bay free. And I want it to output a value of 1. If the input is equal to 7, it means car park is full. And I want it to then equal 2. And so that is then my logic for defining whether it is full or not. To show you that in simulation. So at the moment, none of the inputs are closed, so it is outputting a value of 1 because the car park is free. As soon as all of the inputs close, it equals 7, and then it goes to a value of 2. Perfect. So the next bit is when the car park is full, I want it that the entry barrier cannot open. So the first thing I need is a relay for that entry barrier. I know that I'm going to need a relay for it. Now, there are loads of ways that we could do this entry barrier. We could have very, very granular control or very simple control depending on the motor, depending on the controller of the barrier. I would say that if we're doing a barrier, we leave the barrier controller for all of the safety features, like the safety loop and photo cells, anything like that. And we provide it a simple trigger to trigger it open and then let the timer on the controller close the barrier after the car has driven through. So I could use something like the garage gate controller, but I think it would be a little bit over the top for what we need. And what I really need is just anytime somebody presses the button to get in, it sends a pulse to the barrier to open. But I also want to display it in the app in case they want to manually override it. So I probably want something like a retractive switch. And that retractive switch is then going to be the entrance barrier. The trigger is going to be as you're driving up, like you do in a normal car park, there's a button that you can press to get your ticket or whatever it is. For that, because I'm going to run out of digital inputs, I'm going to use my analog input in my demo case, which is the potentiometer. But what I'm going to do is, as you can see here, I've adjusted the correction of it so that an input value of 10 equals 1. So I have to turn the potentiometer all the way up before it will turn on and be recognized on the retractive switch, just so that I have something to show. Then I need to disable the entrance barrier when the car park is full. The retractive switch block has an input DIS, which disables the inputs, but it can still be used in the user interface, which is great because it means then that a security guard could override it. And so what I need to do is when this equals 2, it means full. So I'm going to have an equal block. And in that equal block, I'm going to say when AQ from the status block equals 2, that then disables our barrier. And you can again see this in simulation. At the moment, we are all good and all fine. There we go. Sent a pulse. If, however, all of the bays are full, DIS is now active and it no longer sends a pulse. Perfect. So that's the entrance barrier locked. I then also said that we needed to consider the exit barrier on a ground loop. I would do that in exactly the same way as this. So another retractive switch, this time for the exit barrier. There would be no disablement on this and it would just be tied to a ground loop. So ground loop and then the exit barrier relay on the output. And then the final thing I said I wanted from the main config challenge was I wanted the entrance lights at the car park to display either green or red, depending on whether there were any cars, depending on whether the car park was full or not. So I'm obviously going to need some lights for that. So I'm going to use the LED strip that is in my demo case already. And I'm going to use a lighting controller. that LED strip is going to go on the lighting controller. On this lighting controller, I am then going to get rid of that bright mood. Don't need it, it's gone. I'm going to take the off mood off of the switch. These lights are never going to be off. They're going to be green or red. I'm then going to create two moods. One mood is going to be free. One mood is going to be full. When we are free, we have a green color, nice and bright and green. When we are full, we have nice and bright and red, just like that. Also going to take the pluses off there as well. I don't want to mess around with any scene scrolling. Free and full, green and red. And the important bit here is the number for AIS, 1 and 2. And that's because there is an input on the lighting controller, AIS, which I can directly tie an analog value to go to a specific mood. And guess what? This status block is already outputting a 1 or a 2, depending on free or full. So I do that, I save in, I switch over to my webcam. When this is all rebooted, there we go. So the car park is currently free. I'm just going to twist that because I'm a perfectionist. So if I go into live view as well, so you can see it both on the webcam and on my screen. So the car park is currently free. I'm just going to open this door contact so the exit loop isn't triggering. So we're green LEDs. Then cars start driving in, and you can see the inputs closing one by one. And when the final bay is full, LED strip goes red. This now means that this potentiometer here will not open the entry barrier. And you can see it just here on my screen share that the entry button is going on and off, but the entry barrier will not move. However, one of the cars leaves, LED strip back to green, and now the potentiometer does open the entry barrier. You can just see that flash on about half-second pulse. You can just see it there on the demo case as well, trigger quickly. If somebody drives over the ground loop and closes it, then exactly the same, the exit barrier goes, and the exit barrier goes regardless of whether the car park is full or not. And that is the main bulk of our assignment done. Final car drives in, red. A car leaves, green. When the car park has free spaces, people can enter. When the car park is full, people cannot enter. And in the app, if I just go to the web interface, you will see that one of the reasons I used a retractive switch was that it shows for me in the app. And the other thing with retractive switches is the ability to set an icon. So we could pick a nice icon that looks like an entrance barrier or a gate, and that will also display in the app as well. And so while that's saving in, let's get on to the extra challenge. So for the extra challenge, we said that when there was a car in the bay, a light would be off. So first thing I want is a new page for my bays, and we want some kind of addressable lighting. This could be Dali, this could be DMX, or this could be locks-on fittings. Up to us. I've put in locks-on fittings because why not? However, I think that lighting controllers are going to be a little bit over the top for this. I want a much, much simpler function block, like a switch block. So I would want a switch block for each bay. So I'd have a bay 1 switch block, a bay 2 switch block, bay 3, bay 4, bay 5, bay 6, bay 7. You get the idea. Now, the only thing with using locks-on lighting for this to consider will be that Loxon lighting outputs by default are something called smart actuators. Now, smart actuators only work with the lighting controller. But what you can do with our lighting products, like I've got here with these LED surface mount spots, is you can change the actuator type to standard. When it is a standard actuator, they will then work on any output. The other thing to bear in mind is that these fittings are dimmable. So they are looking for an analog input between 0 and 100. This is a digital output that will output a 0 or a 1. Very, very easy way we can get around that. Again, on the fitting, we can do correction to say that if it gets a 1, it sends a value of 100 to the light. And that then means that we can put that light onto a normal switch block. So I'll just do the first two for you. The next dilemma is how we get these to actually trigger on and off. So we have an input. Let's just take that Bay 1 input back out onto the page again. But that isn't going to work directly in the switch block because trigger on and off is what we have on the switch block, and it's not recognizing the edges. So you guessed it, because I use it in nearly every config video, edge detection. So Bay 1 into edge detection. And so the important thing here is the way round, because when this sensor goes on, so the rising edge, we actually want to turn the light off. And when this sensor goes off, so a car is left, we want to turn the light back on. So off to on and on to off. Other than that, we then save that in. And then once I'd replicated that 7 times, that would also be our lights in each bay as well. And again, just to prove it to you, I obviously don't have this light in reality, but I can start live view. And at the moment, the bay is currently occupied and the light is off. If the car then leaves the bay, look at that, the light then goes on, so the output is on. And this dimmer as well, although it's hard to see in simulation because it says 1% greater than 0%. Trust me, it does work. You can do correction on a standard actuator. I have, in fact, tested it before we started with this warm white, using the warm white on the LED strip here, and it does work. And so that I would then just need to replicate for all 7 bays. And then in the app, car park, here's our different bays for our different lights. We could, of course, take these off the app if we didn't want to see them. And then we have our 2 retractive switches for the entrance barrier and for the exit barrier. So if I do the entrance barrier, but I make it that all of the bays are full, so LED strip now red, you'll see that that does not trigger the entrance barrier. But in the app, I can still manually override if I need to, like say a security guard. And that is our config solution completely done. And as I said there, door and window monitor as well. We can't change it. It will say open or closed, but as long as we know what we're looking at, it still displays quite nicely in the app. Brilliant. Config challenge solved. Thank you everyone so much for joining. Hope you've enjoyed. Please join me again next time. Goodbye.